Image reveals unprecedented view of the third interstellar object observed passing through our solar system. A new image has revealed the clearest glimpse yet of an interstellar visitor zipping through our solar system. The Hubble telescope and its wide-field camera 3 got an incredible view of the comet named 3I/Atlas, which came from beyond our solar system, on July 21 when the object was 277 million miles, 445 million kilometers, from Earth. In the image, a teardrop-shaped dust cocoon can be seen streaking from the comet's icy nucleus. A comet's nucleus is its solid core, made of ice, dust and rocks. When comets travel near stars such as the Sun, heat causes them to release gas and dust, which creates their signature tails. The venerable telescope is just one of many that are being used to track the comet, first discovered on July 1, as it zooms at a blistering 130,000 miles, 209,000 kilometers, per hour. Its speed makes 3I/Atlas the fastest object that originated outside of our solar system to ever be observed traveling through it. New observations, like those made with Hubble, are shedding more light on the comet's size. The small nucleus, which cannot be directly seen, could be as large as 3.5 miles, 5.6 kilometers, in diameter or as small as 1,000 feet, 305 meters, across, according to a new paper accepted by the astrophysical journal Letters. Meanwhile, other space-based telescopes like the James Webb Space Telescope, the Transiting Exoplanet Survey Satellite and the Neil Gehrels Swift Observatory, along with ground-based observations from the W.M. Keck Observatory in Hawaii, could reveal more about the object's chemical composition. The comet is expected to remain visible to ground-based telescopes through September before passing too close to the Sun to be spotted until it reappears on the other side of our star in early December. But big questions about 3I/Atlas remain, some of which may be impossible to answer, including where exactly it came from. No one knows where the comet came from. It's like glimpsing a rifle bullet for 1,000th of a second. You can't project that back with any accuracy to figure out where it started on its path, said lead study author David Jewett, professor of astronomy at the University of California, Los Angeles, in a statement. While the comet appears to behave like those that originated in our solar system, as evidenced by that dust plume Hubble captured, the speed of 3I/Atlas is one indicator that it's a visitor from another solar system in our galaxy. Scientists estimate it has been traveling through interstellar space for billions of years. As objects travel through space, they experience a gravitational slingshot effect from whizzing by stars and stellar nurseries that increases their momentum. So the longer 3I/Atlas has spent in space, the faster it moves. The comet is only the third known interstellar object to have been observed in our solar system after Oumuamua in 2017 and 2I/Borisov in 2019. 3I in particular is remarkable due to its velocity, said Matthew Hopkins, a recent doctoral student in the Department of Physics at the University of Oxford who authored a separate study about the object. This velocity is very useful to us in particular as over the last few years me and my co-authors have been building a model that allows us to predict properties of interstellar objects, such as their age and composition, just from their velocity. For Hopkins, the discovery of 3I/Atlas was incredibly fortuitous. The find occurred just 5 days after he finished his doctoral work, which involved a lot of time spent making predictions about future interstellar object discoveries. In a few months, he'll begin a postdoctoral research fellowship at the University of Canterbury in New Zealand, where he'll continue to research 3I/Atlas. During his doctoral studies, Hopkins and his collaborators in New Zealand developed the Otatahi, Oxford model, a combination of data from the Milky Way star population and models of how planetary systems form that could help astronomers determine what interstellar object populations should look like. Now, Hopkins is the lead author of a separate preprint study about 3I/Atlas. Spotting interstellar objects in the future. It's difficult to determine the age of interstellar objects, but Hopkins and his colleagues believe 3I/Atlas has about a 67% chance of being more than 7.6 billion years old, while our Sun, solar system and its comets are only 4.5 billion years old, he said. It's pure chance that the interstellar comet crossed into our solar system, but it's not entirely rare, Hopkins said. We just don't see these visitors most of the time. Interstellar objects actually pass through the solar system all the time, especially the smaller ones which are more numerous, 80 the size of Oumuamua, about 656 feet, or 200 meters, across, pass through the orbit of Jupiter every year. They're just too small to detect unless they get very close to the Earth, Hopkins wrote in an email. However, astronomers are eager to have the Veris C. Rubin Observatory, which released its first images this summer, scanning the skies for interstellar objects. With the observatory's massive primary mirror spanning 28 feet, 8.4 meters, across, it can spot small, faint and distant objects, and it's scanning the entire sky every 3 nights, allowing the telescope to better catch sight of rapidly moving interstellar objects.